Hi, and welcome to Supply Chain Today. Here we discuss the latest hot topics in supply chain and global trade with experts from all around the world. My name is Ben, and I'm going to be your host for this episode. Today, I'm joined with our special guest, Partha Sen. Partha Sen has exceptional experience with about 15 years of cross-functional work. He's experienced with prototype development using all kinds of data sets. He has also monitored model performance, supported teams on understanding of the business using data analytics and visualization. It is an amazing opportunity for us to have Partha Sen with us today. How are you doing, sir?
I'm doing good. How are you doing, Ben?
I'm doing great. Thank you so much for joining today. And today's topic for discussion is AI in supply chain. So, on the same topic, we have some questions submitted by our frequent listeners. I hope they will find this episode insightful, informative, and interesting. So, before we go forward, I would like to remind all our listeners that you can submit your questions by clicking the link found in the description. And with no more delay, here are the questions for the topic AI in supply chain. So, the first question: why do we need AI driven product like Kai when manual classification is possible?
This is actually a very common and important question, Ben, to start with. To answer this precisely, artificial intelligence is faster, quicker, and reliable for product classification. Yeah, faster, quicker, no doubt, but really intelligent and reliable.
Mm.
Let's look into the environment. Now, I am considering only the AI-driven products presence in the logistics and supply chain domain. This is helping humans in different ways. A few examples like through load optimization, inventory management, climate prediction, and so on. This is very common now to find the presence of AI in product classification on the web for e-commerce sites that are also helping users by recommending products. In the construction industry, this product classification is helping to save time and cost by creating a product signature, automatically tagging the product, mapping assets to building, plant and manufacturing units. Other common use cases of AI is like mapping engineering bills of materials to business ERP, oil companies. So AI is very
Mm.
ubiquitous, that you understand, Ben. So to many sectors and undoubtedly gates the edge through different applications. Now, the question of speed and reliability of AI is irrelevant, but I need to mention here something very relevant that is more on implementation. So KI is the flagship product of Avaya Solutions, one of the best of its kind by using AI in the core. In this context, we can recall again, it reduces cost and increases the user's experience. This is very significant to note that KI is not to replace humans, but to help our clients by accuracy and speed. Yeah, Ben. So that is the point that the classification is manual to automation through AI is very important, and that is quite relevant in the next industry revolution. Industry, we can say industry 4.0. So this is very relevant.
Yeah, but now we have all this good points about AI, but obviously it will also have some risk, right? So, what are the risks of using AI?
For any AI models, we always introspect. The risk is accuracy and misclassification. So we reached around 85% accuracy in our first round. So when we say round, it's like if you think of the nowadays the self-driving car, if you think of. So we cannot go to the road with complete automation. So here is also the accuracy we think of the round. So maybe by the 5 rounds, we can think that we are ready to go to the road and no human intervention is required. But when it is first round, second round, we think of that accuracy is important. And here that is 85%. And we can reach 95%, 97% by the completion of the all rounds. We are closely working with misclassification. System predicts multiple codes based on inputs with different probabilities. So different probability values range from 0 to 1. that we know if we think of statistically. So probability of 0 is just nothing, and 1 is very highly predictive. So that we are considering here. Now, probability values are different because machine learning models have different confidence in output values based on the fed data. So here, fed data is like whatever the data we are getting from the clients. When any predicted code with a lower probability indicates a lower chance of acceptance by the user. That's in the other way you can think of that when the probability is very high, you can easily accept, and it is very common to understand that this is the presence, this is the excellency of the predictive factors. But wrong predicted code with higher probability or rightly predicted code with lower probability are very risky here. Kai is evolving regularly to reduce this misclassification with close observation. And we are there to observe these things, that how it can be improved with different kind of data, with retraining, with more insight from the clients. Custom is most interested in cases of misclassification where the tax and duty rates that apply to the declared HS codes are different to the ones that apply to the code deemed more probable or correct. So this development can be extended to automatically calculate the new taxes and duties that would apply if this code was used. So the customs can quickly determine if it is financially cost effective to build a misclassification case against the importer. So overall, that we now think of that how the risk and the return both can be thought in this way. So risk is there, but suddenly it cannot be achieved in one day to that return or that risk-free zone. But we are achieving slowly by different rounds.
Yeah, definitely, definitely. That is true. So, what is the role and context of NLP in building models?
Ah, that NLP is very relevant, and it's very interesting thing. So if we go back very early stage of this AI, the presence of NLP was limited. Now the presence is quite high, and in fact, NLP is useful when the context of unstructured data comes into analysis. Structured data is helpful, but unstructured data is just a great source for information retrieval. And if you think of that nowadays, the data source or sourcing data is very cheap and very achievable if we think of the structured and unstructured point of view. So once 10-15 years back, the structured data were available to us, but unstructured data, that is nowadays, day by day, it is very easily available. And now this NLP context is very important here. So different engineering codes, just like I am giving the examples, like different engineering codes, standards, unit along with product description and hierarchy are great sources to get information on product attributes like price, size, color, manufacturing, location, shape, and more. Just I told. So this is nowadays, it is very easily available. And extracting intelligence from this unstructured data and structured data is possible using natural language processing. So this, we can say this NLP or natural language processing the same way. So this NLP output is again a great feed to predictive models, whether it is supervised or unsupervised. So supervised, unsupervised is little bit, we can understand that this is kind of models that we are developing. So when the supervised and unsupervised models would be built with using the NLP, or what I told Ben, that that part of the development is using the both structured and unstructured. So NLP comes here that we will get the information, insightful information from the unstructured data, and that would be a great success. And we can say in the completion of the levels would be if you can use properly this NLP.